Good morning, good afternoon, and good evening, everyone. Thank you so much for joining us for today's session, Building Hallucination-Free Semantic Search Applications with OriginTrail and Milvus. I'm Yujin Tang, and I'm a member of the team here at Zillis. I'll cover a few housekeeping items, and then we'll get right on into the session. First, this webinar is being recorded, so if you have to drop off at any point, you will get access to the on-demand version within a few days. If you have questions, feel free to paste them into the Q&A tool at the bottom of your screen. And for upcoming events, we have one on September 21st that is going to be by me about doing citations and attributions with retrieval augmented generation. And then on the 28th, we'll have the co-founder and CTO of Cradle AI come present about Milvus in action. That's all for housekeeping. Today, I am pleased to introduce today's session, Build Hallucination-Free Semantic Search Applications with OriginTrail and Milvus, and our guest speaker, Branimir Rakic. Branimir is the founder and CTO of Trace Labs, core developers of OriginTrail. Branimir has been the architect and creator of the OriginTrail Decentralized Knowledge Graph, DKG, designed for making AI-grade knowledge assets discoverable and verifiable across the web. Branimir has been particularly focused on networking problems throughout his career, spanning decentralized networks. Apart from DKG, he has also worked on Ethereum and Polkadot, semantic networks, and even mobile networks. Being a strong advocate of open source and permissionless systems, Branimir is active in standards development working groups within GS1 and various blockchain communities, a member of the Serbian Entrepreneurs Collective, and an alumni of H-Farm Accelerator. Welcome, Branimir.
Thanks a lot, Eugene. Hello, everybody. Good morning and afternoon or evening, wherever you are around the world. And yeah, really happy to be here and present what we've been working on lately within OriginTrail in as well conjunction with Milvus. So I hope this presentation is interesting to you. I suppose it's a bit of a different than what usually you would see on Zillis webinars because of the trusted blockchain and knowledge graph angle. So I'll dive a little bit deeper into how that works, but I'll try to stay high level so it doesn't get too complicated. But yeah, feel free to post any questions in the Q&A, and I'll try to address those together with Eugene, I suppose, at the end. So yeah, I guess that we can get started by now. Pretty much, I guess the focus in here. So we're going to be talking about hallucination-free semantic search apps with OriginTrail and Milvus. And I'm going to actually start by introducing the high-level problem here and why we're at all in this space. And just going to highlight the person I'm sure pretty much everybody knows on this call. It's called the godfather of AI, Geoffrey Hinton, who recently left Google, the last half a year ago or something like that, because of the dangers ahead. I'm sure everybody is all aware of the whole boom that happened with large language models lately, and he's credited as one of the people who basically was pioneering this idea, and now it seems to be that he's very worried about what can happen. And very big problem here being that, well, obviously LLMs have this weird notion of hallucination, or really just like sort of guessing something, shooting some output that might not necessarily be at all correct or somehow verifiable. And that's already taking place in the world. So we live in this sort of post-truth world, right, where there's a lot of people generally, labeling things with fake news and all these kind of new labels to things that we didn't sort of hear many years ago before. And now with AI, that can hallucinate and is becoming a bigger part of content creation around the world. The problem just becomes bigger. And there's been, for example, a case of a certain lawyer who did legal research with ChatGPT. Probably it wasn't ill-intentioned, rather likely it was the person was in a rush. We're all in a rush today, right? So, and he ended up citing a couple of non-existing filings, non-existing cases in the filing. So ended up getting in trouble with the court himself because ChatGPT just invented a bunch of these quotations that were leading to nowhere, non-existent. So this is just one of the real tangible examples of this happening. But not just that it's happening, it's also a big blocker for adoption of AI, especially within enterprises. And that's what we're hearing from enterprise partners of ours, where we actually heard quite a bit of them being interested in using technologies like LLMs, but on the other hand, being quite blocked by this notion of, well, it can just spit out anything. So from an enterprise grade perspective, this is still not something that is really easy to tackle. So I suppose this whole problem statement is quite understandable by now, but for everybody. And essentially, we see that this overflow of misinformation is where trusted data really becomes the cornerstone for all humanity, really, but especially for security or systems for really further prosperity. So convergence towards some more trusted and reliable systems rather than diverging into some chaos. And therefore, at OriginTrail, we actually think that it's another knowledge revolution happening right now, that we've seen 3 so far. The first one was kickstarted with the printing press. We had the problem of knowledge scarcity. Knowledge was basically managed, well, in Europe, mostly within entities like churches and rare libraries around the world. And it was very concentrated in a small number of places. Then we get the printing press. All of a sudden, replication comes as a solution to scarcity, and voila, the world changes. And literally, a renaissance happens, and the world becomes totally different and more advanced. And then we have obviously the big revolution, which happened with the internet, which solved the fragmentation of knowledge, which was available around, but with connectivity as a solution, we got networks, we got the World Wide Web. And then, as I'll explain today, we have Web 2 and Web 3 that advance that concept to the next level, where we basically solve this second problem, the problem of fragmentation, and got an amazing knowledge revolution happening over the course of the past several decades. And right now we're in the middle of a new one. And this new revolution, driven obviously by AI, has the problem that immediately puts in front of everybody's face, which is this trust problem. How do we trust the information that we're seeing, and how can we verify that indeed what we're getting, what we've somehow discovered, is indeed something that we can trust? And we believe that the solution to this problem is really decentralized AI. At OriginTrail, we've been building technologies based on decentralized networks for about 7 years now. We actually started way back before that, building centralized proprietary systems. And then around 2017, we realized that we should really expose this technology to as many people as possible. So we went from centralized proprietary to decentralized and open source. So today I'll explain a bit more about OriginTrail, but in the context of this grander scheme of things, the knowledge revolution we're in today, we believe is going to essentially merge and having decentralized technologies support the exploding, amazing world of AI as sort of a kind of a trusted infrastructure underneath. So essentially at OriginTrail, we like to say that knowledge is a new asset class. And therefore, OriginTrail is technologies to let you seize it. So I'll explain today the concepts behind OriginTrail and how it ties in with Milvus in particular, as well as with AI. And I'll show a small demo application just to illustrate how this works in actually a couple of different cases. But before that, I'll have to make a bit of an introduction to OriginTrail so that it's actually possible to follow what I mean by trusted AI infrastructure. Just as a note, OriginTrail is not some laboratory technology. It's actually been used for many years by businesses around the world. Some of the examples are seen here on the screen. I won't go too deep into them. If you're interested, you can see a lot more information on our website, but I'll just highlight four. One is the Trusted Factory case, where British Standards Institution, together with the biggest US retailers such as Walmart, Target, Home Depot, have built a system on top of OriginTrail to share security audits for factories around the world, covering actually 40% of US imports. So all of this built on OriginTrail Decentralized Knowledge Graph. Rail travel safety is another case where we work together with the Swiss railway company for many years. They're basically tracking all kinds of things within their railway supply chain, including trains across Europe, minimizing really the safety risk. And probably if you're in the US or where I come from, in Serbia, we had a couple of rail incidents in the last year or two that were really catastrophic, both for the environment and people. So these types of cases is where trusted knowledge sharing really can help, because it's actually a big problem for this old school industry in a way to aggregate all of this information and, as well as in a trusted way, access it. Food and beverage traceability is also another case. I'll show you something today regarding that, but basically we've been very active in this industry, following things from whiskey to perishables and dairy products. And since a couple of years ago in the pharmaceuticals as well. So systems built on top of OriginTrail have been used to track vaccines and medicines all the way from US to India, and actually make sure that they really reach the patients rather than end up on some form of a black market. They like to call it diversion, but I like to simplify it and say it's stealing. So the technology helps make sure that this doesn't happen. And these are just some of the cases. There are other applications as well. You can, like I said, check it out on the website, OriginTrail.io. So I'm going to try and explain how that works, actually. The core of OriginTrail are these things called knowledge assets. Like I said, knowledge is a new asset class, right? So I'll try to explain on a high level, how do these knowledge assets work? What are they? What can you do with them? So I'll try to explain with a few slides, and I'll show you very practically how one looks like. Knowledge assets are these containers for knowledge. They're basically verifiable boxes for knowledge, if you want, like that. And what you can do with them is you can create and own them. So basically, if I were to create a knowledge asset right now, I could take some knowledge from a company or personal knowledge, let's say from a device like a smartwatch or whatever, and I could structure it in a knowledge graph way. I will show that in a minute how that works, and create this knowledge asset on OriginTrail Decentralized Knowledge Graph. When I do that, an NFT actually gets created. And this NFT is there to represent this knowledge asset. So in a way, it is the container for this knowledge asset, meaning that it signifies that I'm the owner of this knowledge, as well as it enables me to modify this knowledge. So only the person who has this NFT is able to update this knowledge asset over time. And on this brief animation here, you can see actually a knowledge asset created with an ERC721 NFT attached. This is not a monkey picture NFT. The point of the NFT is not to look cool or make you be part of some community. Rather, it's a technical component, and it's used literally for administration of this knowledge asset. So it's not, you wouldn't normally, see a person running around with a shirt of it, but you might expose this NFT to any type of knowledge marketplace, NFT marketplace, where you could literally create very rich knowledge assets and then immediately utilize all of this blockchain Web3 infrastructure because of the standards and the wallets and everything that enables it. Once you create and own your knowledge asset, it becomes discoverable in the decentralized knowledge graph. Basically, it gets this unique asset locator, which is a successor of the URL, the Uniform Research Locator, which enables you to really load this knowledge asset. And this animation briefly shows it. I'll show it again later. But essentially, whoever has a URL can access this knowledge asset and can see all of its contents. And actually, apart from seeing all of the contents, you can also verify basically the origin and the trail of information trail of this knowledge asset. And basically what that does is enables you to see who was the issuer of this knowledge, which is really a set of statements. And then you can also verify the integrity of the information that you read, so that the interface itself, trust is, like I said, a big component of this. So the interface, the website itself that you might be seeing this through, or some mobile app, cannot even trick you. So there's no way that in the transmission from the original source to whoever is querying this knowledge asset, there's no way to modify the information, do some sort of man-in-the-middle attack, because whoever's querying this at the end is able to actually verify the integrity on the blockchain. And I'll explain that in a very short one of the next slides. But essentially, the point being is that both the origin, the source, and the trail of updates, including the creation, is something you can see on the blockchain that has tamper-proof blockchain proofs. Finally, when you have all of this, you can use this knowledge, these knowledge assets to build trusted AI systems. And that meaning whenever your AI system queries the knowledge assets, you can see the source, you can verify the integrity of the trail, and you can make all kinds of interesting queries on it, because you have this assembly of trusted knowledge assets, essentially. And I'll show that today. So if this wasn't 100% clear or deep enough, that's for a reason. Trust me, I've been giving this presentation for a while, and because it combines blockchain, AI, and knowledge graphs, it can get a bit confusing. So I'll try to reiterate some things over the course of the presentation. I see a few questions where I can quickly maybe answer them. There's a question: which chain are the NFTs created on? It's a very good question. And I'll quickly answer it, and then I'll add some more context later. OriginTrail is actually a decentralized knowledge graph. It's not a blockchain network per se, rather it's a multi-chain decentralized knowledge graph, connects to different blockchains. And when it was launched on Ethereum 2018, apologies, and then we expanded the network to a couple of other blockchains such as Polygon, Gnosis, and since recently, about a year ago, also on the Polkadot parachain, which was custom launched for OriginTrail. So it's called OriginTrail parachain. However, long story short, the point of this technology is that it's neutral, so that it lets essentially each blockchain community who wants to integrate this technology to be able to integrate it. So the answer is whatever blockchain community supports the decentralized knowledge graph is where you can basically mint your NFT. So when you create a knowledge asset, you say, I want this knowledge asset NFT to be minted on Ethereum or on Gnosis or on any other chain. So that's like the quick answer, and I'll explain a bit later how it actually works in more detail. Another question is, will using blockchain reduce the bandwidth for data access? That's also a great question. And the short answer is no. So the bandwidth for access is not constrained with the blockchain. However, the bandwidth for publishing, introducing new knowledge in the decentralized knowledge graph obviously is. And then there's two types of bandwidth we're looking at here. One is, let's say, the frequency, how many knowledge assets can be created over time. And the other one is how big these knowledge assets can be. So I'll save that explanation for a bit later for the right slide. So maybe the question can remain open so I don't forget. But essentially, on half of the answer, meaning the bandwidth for access, is actually not affected because it doesn't go through the blockchain. I'll show you that in a minute. So, okay, I'll basically explain this in a bit more detail because it can get really complex. What you can visualize is essentially a three-layered architecture. This layer one being these multiple blockchains that I mentioned, or we call this multi-chain consensus layer. OriginTrail layer two would be this decentralized knowledge graph. It's its own network. It's one network. If you've ever had contact with Web3, you can sort of put it in a similar bucket as something like IPFS, which is a data storage network, which is also peer-to-peer decentralized network, however, it doesn't have consensus. So it doesn't have the throughput limitations. Essentially, nodes in the IPFS network, also in the OriginTrail decentralized knowledge graph network, they don't need to reach consensus because data is essentially replicated. The difference between IPFS and OriginTrail, though, is that IPFS is really for data storage, while OriginTrail is more like your knowledge graph, like a database, right? So you can send different types of queries. It has more structure, adds obviously knowledge graph features to it. However, many different nodes, currently around 155 nodes running the latest version of OriginTrail version 6, are dispersed around the world. Anybody can run a node. So whoever's on this call today can just like go to our website, download the node, run it on their computer or cloud environment, wherever. You can tune in, and after you set up your node becomes part of the network and it starts hosting knowledge assets. It actually gets compensated for hosting these knowledge assets. So if I were to create a knowledge asset now, just as using a blockchain for, let's say, if I want to send a transaction to somebody, I have to pay a fee. In the same way, if I want to create a knowledge asset, I have to pay a fee. And the fee doesn't go to like any central body like me or our company. No, it actually goes to the nodes that are hosting this knowledge graph. So all of the knowledge assets essentially get replicated according to certain essentially DHT-like principles, so that the knowledge is content addressed on the network, as well as replicated, so that there's a very, very minimized a chance of failure. And all of the knowledge assets are accompanied by certain set of tokens, which the nodes who are hosting them actually get after they finish hosting them. So it's kind of a pay-as-you-go system. Finally, on top of this two-layer infrastructure, we see knowledge asset applications. So applications such as the one I'll show today that basically use these knowledge assets, that verify this knowledge, create it, connect it, and query it, and so on. So like I said, to recap, this is a multi-chain decentralized knowledge graph. It's actually based on standards such as W3C decentralized identifiers, verifiable credentials data model, ERC standards from the blockchain world such as 721, for NFTs, GS1 standards, which are actually very relevant for supply chains such as the cases I mentioned before. These uniform asset locators that I mentioned are basically standardized identifiers for knowledge assets. And when I touched upon OriginTrail parachain, I actually forgot to highlight one more thing, which is that soon, and that's one of the reasons why it's there, soon it will start running incentives for knowledge creation. That means literally you come, you create some knowledge, and you get some tokens in return. So the OTP, OriginTrail parachain token, is designed essentially to incentivize knowledge creation and running this infrastructure, much as, for example, Bitcoin is designed to incentivize infrastructure runners, miners in Bitcoin, and so on. There's a lot of use cases because this is very widely applicable technology, like knowledge graphs. You can do all kinds of things, recommender systems, search and discovery engines, QA systems, but also something that doesn't normally associate with knowledge graphs, which are usually centralized, such as knowledge marketplaces. That's one of the cooler things as well. Knowledge aggregation, multi-party verification of different statements, and so on. So that's, I guess, the shortest possible explanation of the three layers and how they connect. Having that said, how does one knowledge asset look like? So this is like an anatomy of a knowledge asset. We have knowledge obviously at the top. The knowledge contains some knowledge, and now that particularly means RDF structured knowledge in this case, because it's a knowledge graph world. RDF can be produced easily from JSON LD. If you ever ran into JSON data structure, you probably have if you're a builder, but JSON LD is like an extension to that. It makes this JSON object really a graph object. And here you can see an example of an entity in a knowledge asset that describes an event. And actually, this is the conference we're organizing a month from now. You're all invited, by the way. It's also going to be online and offline. And this event has basically a certain identifier and has certain connected objects to it, such as a location, which also has a type and so on. So this extension of context type, ID, and so on, this is basically kind of the extension on top of JSON that allows JSON, like simple key value structures, to become actually graph-based structures, and then it can be converted in this RDF. So think of creating a knowledge asset as creating such a JSON LD object, and then you can run this command with basically dkg.create, and it would replicate this knowledge across the network. It will produce this uniform asset locator, which looks like this, did DKG something. Actually, this did means decentralized identifier, contains a bunch of things. Not to go into the depths, but what's really cool here is that it's self-dereferenceable. So you don't need like a DNS, another centralized system somewhere. Rather, your client can just really read this, your browser, and can understand, this is the blockchain I need to go check the record on. This is the contract in the blockchain. This is the actual graph entity that I'm looking for. So there's no way or no reason for any intermediary or some sort of centralized index for that. That actually, this DKG index at the bottom is basically implemented in this way. So this URL enables you to query this knowledge, but also to find this knowledge NFT and to get these knowledge state proofs. A state proof, if you're a developer, you probably use Git and GitHub. Let's say when you make a Git commit, you get a commit hash, right? Well, that's a very similar thing here. So this is essentially the hash of the knowledge above. However, it's not just a simple hash, it's actually a Merkle hash, which allows us to do some very cool things. Again, a topic on its own, but essentially, long story short, for specifically from the blockchain side of things, as you can see, the pink parts are what is stored on the blockchain. So the blockchain hosts only the NFT and only these small hashes. So that means we have used the blockchain in sort of a minimal way. That means transactions are pretty cheap. We're not trying to put a lot of data on the blockchain, which a lot of people try to do. From our experience, is not a good idea. And there's some very simple reasons for that. Well, it's not designed for it. It's not a database. So even if you put a bunch of data in there or knowledge, you don't have a query engine embedded in blockchains. And it's really expensive. Whatever blockchain you take, it ends up being prohibitively expensive. So essentially, the OriginTrail DKG also solves this end of the problem, making a decentralized network that is not prohibitively expensive. And it enables that through a couple of different ways, but also it uses the properties, basically inherits these properties of the blockchain. So, for example, I can take an arbitrarily large piece of knowledge, say, 10 megabytes or something, which normally you cannot fit in any blockchain, like in one transaction. Usually limits are far less in kilobytes and less. But anyhow, I can take a kind of a large graph and I can produce this Merkle proof, and only this hash, this thing, which is a 32-byte hash, ends up being a value that's on the blockchain. And what's cool about it is then I can take only a piece of this graph, any piece, and I can produce something called a Merkle proof to show that actually this thing is included in the entire knowledge asset. So these are called inclusion proofs, and you can essentially compute them without any need to trust anybody. You can just trust the math, and you can compute that a certain piece of content, for example, this name here, is indeed in here, even though you might not even have the entire content. So that's another whole other story, which I won't go too deep into right now, but happy to answer any questions on that later. And essentially, these knowledge assets, like the four things connected, the NFT, the proofs, the URL, and the knowledge, they live across these two layers, and they enable all kinds of cool things. So one of the cool things, and what I'm going to show today, is really this synergy of symbolic and neural AI. So the idea of having a knowledge graph which has very highly structured data, combined with the idea of having very unstructured access to data and approaches such as getting a bunch of text and vectorizing it, creating embeddings, is really an interesting one, especially lately in the knowledge graph world. This connection between the two approaches enables creating very interesting knowledge graph embeddings and solving very interesting knowledge graph problems, such as link prediction or completion of knowledge graphs. Again, huge topic, very interesting for research. We believe is going to be one of the next breakthrough areas in the world of AI. And having that said, there's going to be a lot of things that are going to happen on the generative side of things. However, today we're going to focus on a bit of a different thing. We're going to focus on not so much on generation, rather searching through existing trusted knowledge. So I'm going to show an example knowledge asset application. But before that, I see a couple of questions which maybe expire in people's minds before I go into. So I'm actually going to make a short break to answer these questions. Question is, do node operators get paid in OTP or trace? Aha, okay. Lots more explained on the OriginTrail website, but briefly, the two layers that you've seen, there's a blockchain layer and knowledge graph layer. The knowledge graph layer nodes are compensated in trace track tokens, really, for knowledge publishing, and that's the utility token of this layer. However, on the blockchain layer, the utility is blockchain transactions, right? So whatever blockchain you use, you have to use the token of that blockchain. In the OriginTrail parachain, that token is OTP. However, if you're publishing valuable knowledge, and that is something that the community decides, by the way, you actually get OTP as a knowledge publisher back. So you spend trace, but you get OTP. It's a little complicated, but there's an open RFC right now, an OriginTrail community RFC 18, which explains this, and it's available on our GitHub. So super happy to share the link later. How does publishers are validated for gender? Okay, I'll understand that question is, how do we know the knowledge somebody publishes into the graph is really true or not? And the short answer is we don't. The short answer is essentially anybody can publish anything. So such as on the internet, like the internet is a free environment where anybody can just put up anything, right? So it doesn't have to be true. And that is from an infrastructural perspective. If I go back a couple of slides, like somewhere here. So if you look at this super simple layer infrastructure, basically the colored part is the infrastructure. The infrastructure of OriginTrail is designed to be neutral. There is a certain set of principles such as neutrality, inclusiveness, and usability that we have always used to guide the development of the entire ecosystem. And the big part of this neutrality is infrastructure, we believe, needs to be neutral. That means the infrastructure should not be able to decide if something is true or not. Essentially, today, we don't have an algorithm that you input something into and it can tell you this is true or not, right? That doesn't exist yet. However, we are converging to something of that sort. And something of that sort is definitely needs what this infrastructure provides. So it provides the ability to verify a source who published something, that indeed they published that in certain form. That's why these blockchain proofs. But then also it provides the ability to connect different statements that other people have published. So a lot of people can publish a lot of things. And in a very kind of simplified way, knowledge asset applications get to decide how to make sense out of it and to understand if something is valid or not. So for example, we can take, let's say, multi-party verification system. Imagine that there is a certain set of statements that were made by many parties. Like one statement says that, I don't know, right now it's daytime in San Francisco. And it's okay, that's something you can easily check if you look out of your window. But also you could sort of think about it as many different parties can attest to this, creating statements in the knowledge graph or something else. This is similar to the system of consensus. You can see that also in blockchain oracles, for example, systems like Chainlink, or generally blockchain consensus. The idea being that there's multiple parties that somehow converge and based on some rules say, aha, this is true. However, such a rule is not embedded in the infrastructure. That's something that can be done on the application level. Point being is that the infrastructure is used to get all of the things somehow together, aggregate them, enables you to query them, and then when you get them, knowledge, you're able to then assess, aha, what is this source? Is it Fox News or CNN or whatever, Russian TV, or and then based on that source and source reputation, which also is, by the way, not part of the infrastructure, something we see as part of the application layer, you're then able to discern and make a decision. There's a project within the OriginTrail ecosystem that is building something, they call it the truth chain, which actually enables certain primitives for verification of content However, it's an ongoing area of research and building. And then the question, wouldn't that influence possible bias? Well, we see bias from kind of a different angle. For example, if somebody's, if you're used to, let's say, the knowledge graph world, and by the way, knowledge graphs exist within companies such as Netflix. They use it to recommend you what you should watch based on your history. Or Google, they invented the knowledge graphs. Or Uber uses knowledge graphs. A bunch of companies. They basically use it to integrate all kinds of information, but they use it in a centralized way and they govern it. So it's biased, let's say, towards them and their use case and what they believe and so on. OriginTrail is different in that source because we make sure that the technology itself doesn't have integrated, let's say, bias in that sense so that it goes towards whatever, us or builders of OriginTrail. Rather, anybody can publish anything, can connect anything to anything else, just as like on the internet. And then it's up to you when you're building applications on top to use this in a clever way and to somehow make sense of it. But the bias itself, what we see from an infrastructural perspective would be if there were some sort of specific, let's say, filtering techniques or some decisions on the content which the infrastructure itself would enforce. That's why the infrastructure at all doesn't enforce any content, anything on the content. Rather, it enables you, the more, let's say, the more standardized you make things, the nicer you structure the knowledge, the more you use standard, the more you make it let's say queryable, the more discoverable, the more people will be able to find it. So essentially, it only kind of incentivizes structure, but it doesn't incentivize any content and so on. So I guess that's kind of the quickest, shortest answer. And because we don't have a lot of time, I'm just going to keep going to show an example. And like I said, I'm going to show an example applications. There's a lot of different applications that can be built on OriginTrail. This is just one. I encourage you to go see more on the website. But this one is going to be about extractive question answering based on Milvus and OriginTrail. And I actually have a quick diagram, and then I'll go into the app. So on this diagram, we have like, let's say 4 entities, 5 really, but logically there's 4 of them. We have a trusted AI application on the left, which uses OriginTrail knowledge assets, OriginTrail DKG. Somehow this is able to find knowledge, and knowledge that was obviously created from some knowledge source previously. So if you remember the slides at the beginning, I said we can create knowledge assets and own them, then we can discover them, we can verify them and use them. So we're going to go through the same process here. Imagine there's a knowledge source, and I'll show you one of those. Knowledge source, you can create knowledge assets from it using, for example, running an OriginTrail node. You can do that. And the cool thing you can do is then connect it with Milvus. So you can basically create embeddings from this knowledge and populate a Milvus vector DB, finally publishing these knowledge assets into the knowledge graph. So once you've basically created and nicely structured and vectorized this knowledge, publish it into OriginTrail DKG, and you make it discoverable. So a trusted AI application, such as, let's say, QA system, can discover this knowledge, as you can see in this later step. And then one of the things that it can do, for example, which we'll show today, is imagine the user types in a question or pronounces a question or whatever, somehow comes up with a question, looking to find a trusted answer. You can normally do that with like just Milvus. You could do some sort of vector-based search over some knowledge base or a set of indexed information in the Milvus DB, and it would return vectorized, basically vector search results based on similarity, right? Which is really great. And the great thing to extend it as well is the knowledge graph queries. So for example, we, instead of just answering the questions directly by similarity search, which can also do some really great things, we can also determine the intent of a question by finding vector similarity to let's say other questions or content that's available. So in this application, I'll show you we've done that exactly. So basically we determine intent, and when we determine intent, we know, aha, this is actually fitting certain set of knowledge graph queries or one query. And in this particular case, it will run a query directly on the knowledge. So it's like a database query. In our case, because it's using semantic web standards, this is a Sparkle query, and combines that with the result of similarity search to finally produce a set of results. And all of these results are, again, extracted from this combination of technologies, OriginTrail, Node, and Milvus, which we like to call a knowledge bank. There's a few other details in there, but for simplicity, these are the two main components. And then extracting this information, you can also verify the source and data integrity on the blockchain. And I'm actually going to show you that very quickly in another browser window. So just a second. Somewhere here. Yes. Okay. So refresh that. So, okay. So this is an example application. And I'm going to show you this part. So obviously I cannot show the whole flow. So we already created knowledge assets. And I'm going to show you, for example, I have two examples here. So an example in one of the agri-food cases we're working on. So imagine simple chatbot, but has kind of two modes. One mode is to extract information, to basically just do these queries. Or there's a kind of another one which extracts and summarizes using an LLM. So I'll show you both, but essentially, I'm going to ask a simple question. I just need to give you a context for this case. So what this particular demo is designed for is, as you've seen, I haven't shown the discovery step. Imagine you went into a store and you bought a piece of poultry, basically like, I don't know, chicken legs, something like that. I'm saying this because this is actually a real case that we're working with in Europe. Imagine you scanned a certain code to get to this URL. This would, by the way, be also standardized, the new version of the barcode called GS1 Digital Link. But anyhow, long story short, imagine you somehow got this product, you scanned it, and you open it up on your phone, and you're basically now chatting with trusted knowledge about that product and that brand. So I can, for example, ask something like, where does this chicken come from? Or which farm, probably better, which farm does this chicken come from? And if I click search, what happens under the hood is actually what I showed you here. So I'll try to maybe somehow move it a bit. So this side, basically, it's now determining intent by contacting the Zilis platform, which provides hosted Milvus instances. And essentially, it's taking a bit, I'm not sure why it's so long, but here it is. And after that, it actually runs a knowledge graph query. So the result you see here, it's not the prettiest, it's not like your nice chat GPT, but this is just an example, which actually shows these triples from the knowledge graph. So it says this is the farm ID, this is the product ID. The owner is Stanislav Volk, because this is actually an actual farm from Slovenia, and shows the certificate URL, a couple of things. But like this is basically the content that was found based on having very high certainty on the intent of the question, and then running a standardized graph query to find the farm. Basically also showing the key component, which is the source knowledge asset with the URL and owner. If I open this source knowledge asset, we're actually going to be able to explore it. So this is actually just now read from OriginTrail Decentralized Knowledge Graph. If I zoom in, you'll see the farm has this type and place, like I said in JSON LD, Stanislav Volk, with the address and a bunch of other content, including like a photo, for example. I guess if I will open this link, or I need to save the image. Okay. Oh no, here it is. So this is the photo of the farm. There's a bunch of other connected knowledge assets to it. For example, if I click here on these symbols, the graph starts growing and it opens up additional knowledge assets. And somehow I messed something up here on the demo. So I'll just open up the original knowledge asset again. Here it is. And I'll show you actually the other part. So this is the NFT that was minted for this knowledge asset. and you can see it was minted 50 days ago, and it, the owner and so on. And this is, by the way, on the testnet, so as perhaps a few glitches here and there as a demo, but you can also see that this knowledge asset was basically updated a certain amount of times. And for each of these updates, you can see who is the issuer and the state hash of this particular update. You can also see all of the content in terms of these graph resources in here, so you can explore them through this interface. Now, this interface is a generic interface, which is very similar to Blockchain Explorer. If you go to a blockchain like this, this is a Blockchain Explorer. You can see all of the transactions on this blockchain. For example, for this one, we can see the minting transaction for the NFT, and it shows how many tokens were spent and so on. Very similar way, this is the DKG Explorer, and we can basically see all kinds of interesting knowledge assets there. I can also run, for example, a different question. I could say, let's say, this does this, let's say, what are the characteristics of this meat, for example? What are the characteristics? And if I do that, there's also another, basically this one was quicker. Essentially, it went and took a bunch of graph results. It found the product description, the product URL, the image, and so on. Or if I were to do the same, if I were to send this now to an LLM, obviously the LLM would make this look nicer. So I can do that. I can just say, again, what are the characteristics of this meat, but I switched from extract to extract and summarize mode, and now there's an LLM involved. However, this LLM has much less chance of hallucinating again, because we basically gave it all of the content, and the prompt essentially says, take this and structure it a little nicer for humans. So it basically gives you kind of a nicer representation of the same knowledge that was extracted. We can also open up these knowledge assets, and we can look into all of them. So there's a bunch of different ones, and in that sense, so this is one like example for the food industry. I can also show you this medicine example, which, for example, and I can even do that with audio. We just recently tried Google's AI model tool, really called Chirp. So I can try and record it if I have a second. Let's see. Let's say with this, let's say I scan the medicine now. I can ask it, can I, let's say, take this medicine with alcohol? Actually, let's do that. Can I take this medicine with alcohol? This interface is not the nicest. It's a demo, but I got the question. So there was some basically NLP involved, and then the result was basically just a simple semantic search on the knowledge asset, which found that taking your mackerel with alcohol is something you should not do, obviously. So if I were to open this knowledge asset, I will see actually quite a rich knowledge asset with a lot of information that was produced from the leaflet of this medicine. So that would be a very, let's say, simple application that, and I'm going to go back to the chart here, that used knowledge assets created from certain sources, which you can see who they are. Basically, you can see the identifiers on the blockchain, basically wallets that publish this. And because they were nicely structured in the knowledge bank, they could be discovered and then used through such a question answering system. And one of the big reasons why DKG is so special is it's because designed not to be a system where everybody uses their own centralized entity. Rather, it's a decentralized knowledge graph. So many different people can collectively basically populate it. And with populating, they can also connect different knowledge assets to each other, building such a large trusted knowledge base together. And with this, therefore, this incentivization mechanism is what is really interesting, and we're excited to see it kick off in the near future, so that basically we can get some really, really high quality trusted knowledge. Basically, the biggest knowledge graph in the world is what OriginTrail is aimed to become. Also, in order to do this, we have launched a grant program of 1 million track tokens within something we called ChatDKG. So, pun intended, of course, this program, ChatDKG, is really a builder's program for building trusted AI tools basically to fight misinformation and based on knowledge assets. If you were to scan this QR code, it would lead you to the website ChatDKG AI, which is really a repo, where you can find all the details about this program, including how you can apply for grants and which type of applications qualify. For example, question answering systems similar to the one I just showed, which are open source and which you would build together with the community, is something that qualifies for such grants. So if you're a builder, head over to the website and we'll be super happy to meet you. Also to meet you in our Discord. So having all that said, and since we're almost at the end of time, I'm going to close it here with one final quote from the late founder of Intel, Robert Noyce, who said, "Knowledge is power, but knowledge share is power multiplied." And that's the motto we go by at OriginTrail. Thanks, everybody. I see a bunch of questions, but before we jump into them, I'll quickly head over to you, Eugene, to continue, I guess, with this question answering, or just give maybe your thoughts on the topic. How much time do we have left, by the way? Is it 8 minutes?
Yeah, we've got like 8 minutes left. Let's just let's
Awesome.
jump into the questions. There were quite a few questions, so I think we can just address the questions first, and if there's time at the end,
Awesome.
I can give some thoughts there.
Awesome.
Okay, so you can start with the first question if you would like.
Sure. Yeah, I'll go ahead. Maybe hallucination is part of the ambiguity of natural language. That's the reason that humans invented math. How are we going to resolve this dichotomy between NLP and accuracy? Oh, actually, the way I understand this question, I actually really like it because you said something really interesting. Ambiguity and math. In the world of knowledge graphs, math is equivalent to essentially this way of representing knowledge. Semantic web technologies such as RDF and something called ontologies. So, for example, the math of the knowledge graph is really are these ontologies where you define a certain knowledge domain. And that is really cool because if you define a certain knowledge domain, it's very similar to essentially mathematical logic. And therefore, you can do inferencing on the knowledge graph level. So, for example, you can do some very simple inferencing from the capabilities of graph connections to be exploited, such as inferencing that somebody is a relative, and what usually this is used for with knowledge graphs, by the way, is often fraud detection. So there's ways to detect similarities in graph structure based on this inferencing. It's a very, very wide topic, but essentially it's a really good grounding tool or ambiguity that we can get with NLP and generally accuracy. So I encourage looking into knowledge graph inferencing and ontologies to go deeper into this topic. Again, these are just tools to help with this, so they don't solve the entire world. Okay, I'm moving on to the next one. I missed the step where the use of an LLM is justified. You can already query your knowledge base exactly without errors using Sparkle by putting vectors of your ontology into an LLM query. Are you just getting a human language query interface instead of Sparkle? To an extent. You are adding a much easier way to interact with the knowledge in the knowledge graph. And essentially, if I were to go back on this chart, you won't see DLM. Of course, there was a population of embeddings within the creation step to enable easier search, and vector similarity search is a component of this example application, as I said. And that makes it easier to query with natural language, which is really important because not a lot of people know Sparkle. And I believe that one of the big reasons why this whole great idea of semantic web, which is embodied today in knowledge graphs, is exactly because it was too complex. like Tim Berners-Lee, when he came up with it, which was 20 plus years ago, it was great. It was an amazing idea, but it became really complex. And one of the reasons is, this usability. So that's why reusability is a big principle behind OriginTrail. It has to be easy to use these technologies. And this is one way to make it much easier. But yet again, you're not querying an LLM to generate an answer to you. You're really just vectorizing a question at best. And then ideally, you're not just using a very basic vector similarity search, you're somehow trying to figure out the intent of the question and then do a very strict, I may say, knowledge graph query. Okay, one more question. And if so, how do you mitigate the errors because of the approximate nature of vectorizing? It's a very good question. It relates to what I just said briefly. So the idea would be that instead of observing this is a system, that's why we called it actually Trusted Semantic Search app. Instead of thinking of it as question has one right answer, such systems that provide you with search results have a bit less of a promise to give. So they don't say like, I'm telling you the truth. Rather, it says, I'm giving you a set of results from a database or a knowledge graph that you can verify the sources, the integrity, and all this information, but also you can then decide what you do with it. So ultimately, the end application is responsible for somehow handling all of this information, exactly because of that topic we mentioned, the bias in the beginning. So, long story short, minimizing the use of LLMs, maximizing the use of knowledge graph queries, and then also not sort of making the final decision for whoever's making the query, rather than enabling sort of discovering this information through kind of a search result system. So that would be the shortest possible answer with the little time we have. But thanks everybody for the great questions. This was totally on point and on spot.
All right, that was a great last question to end up on, and we also happen to be running up almost right on the edge of the hour, so we only have a couple minutes left, and let's wrap it up here then. Thank you everybody for coming, and thank you, Branimir, for a great presentation.
Thanks a lot for the invite, and thanks everybody. I hope you could follow. Feel free to jump into our Discord if you want to continue the discussion, or reach out to me on Twitter, LinkedIn, Telegram, or wherever. I'm everywhere. So thanks again, everybody. Have a great day, the rest of the week.